good side, then just greet her and say, my name is Tape Diagram. She will be your best friend forever. Now, with that said, this is our standard, okay? Fractional models, we're focusing on that tape diagram. We're going to see how the number size of the parts differ even though the two fractions themselves are the same size. They're different, but they're the same. Kind of like that candy bar, right? It's the same candy bar, but it comes in different little pieces. That's right, those pieces are part of the whole. So, now, we're going to use the principle to recognize and generate, what's these? Equivalent fractions. All right. So we're going to go to sleep dreaming about stuff that are the same but look different. Okay? So we're going to look at those equivalent fractions. All right. Quickly. Yep, that's right. Just like we did yesterday. Because everybody remembers the candy bars, don't we? That's right. That's all I got to do is say candy bar. Remember that. All right. So let's go ahead and look at our journal entry for today. All right. So go ahead. Ooh, I believe we're like at a 105 or something like that.
Yeah.
Fantastic. I love it. Fantastic. All right. 105. This is fantastic. No, we are not at 105. We are at 106 and 107. Let's go. 106, 107. All right. Go ahead and have your glue sticks ready to go. And I have our little insert for today. Equivalent fractions. Mine is how do we prove two fractions that look different are actually the same? So I want you to take that. I want you to put that in your head. Okay, that's going to be that lingering question that's in my head. How am I proving that two different looking fractions are actually equal? All right, everybody have their little quarter sheet? All right, fantastic. And I got mine, got my glue stick, ready to rock and roll. All right, remember four corners? Do not need to make it hurricane proof. And we're going to go right there at the top. And let's go ahead and remind ourselves of the standard. Let's go ahead and put the standard up at the top. What is our standard? I forgot the numbers already. I know, I'm getting old. I'm forgetting stuff like my name and stuff like that, but you know. All right, what is our standard, Mariah? NF 1.1, fantastic. Now, I can't write everything up there, but who can give me a summary of what our standard is? NF 1.1. Just kind of give me a quick little summary. Danielle?
Equivalent fractions.
That's right, equivalent fractions. Can I get a little bit more? Can I get a little bit more? I love that summary. Can I get a little bit more, Benjamin?
We're trying to figure, we're taking two fractions and seeing if they're equal in that.
That's right. We're taking two fractions and we're seeing or proving that they are either equal or they're not equal. Very good. I love it. Very good. All right, NF 1.1. Well, as always, I guess it would help if we had an official definition, you know, because of that whole vocabulary quiz thing that we do, you know. So let's go ahead and write down the official equivalent fraction definition. So an equivalent fraction, different fractions that represent the same amount. So let's go ahead and write that word equivalent. E-Q-U-I-V-A-L-E-N-T fractions. So we're going to go ahead and take our equivalent fractions. I don't know why my camera's not being nice to me today. And then go ahead and put your pencil down to show me that you're done. All right, so like I told you guys earlier, this is going to become your new best friend. Other than the place value chart. You have a new best friend, and his name is Tape Diagram. He's going to be your best buddy forever and ever. You guys are like going to be BFFs. Now, this is a way to model, to show how we get equivalent fractions, okay? So I'm going to go ahead and show you how we do the tape diagram. All right, now you'll notice that on yours, the first two are shaded. Let's go ahead and shade them in just a little bit more, just a little bit. That way it'll show up on the screen a little bit better.
Yeah, it's not sure.
Okay, so the first thing that we need to do is we need to remember that this diagram represents one whole, right? But we're not looking at the whole. We are only looking at the shaded part. So before I look at the shaded part, I need to label my tape diagram, right? So I need to kind of find my UF. So what is my UF here? Oh, and who can explain to us what is the UF? And not University of Florida, because we don't root for them. Okay, what is the UF? Okay, Blair.
UF is the unit fraction.
That's right. So we need to find that unit fraction. So who can help Blair find the unit fraction for me? All right, Bentley.
First we count the boxes, and then once we find out, we put 1, and then whatever number, we count it from the back.
Okay, and why is 1 going to be the numerator?
Because if there's one part of the denominator, it's a part of the whole.
Okay, so he's saying that we're looking at just one part, which is going to be the numerator, and the total number that we counted is going to be the denominator. Very good, and that's how we find our unit fraction. Very good. All right, so there's 1, 2, 3, 4, 5, 6. So that must mean that my denominator is going to be a 6. Now, I like to kind of write it up here. So my UF is going to be a 6, 2, 6. Very good. All right. Rock and roll. So we do have 2, 6 here. Okay? Now I want to go ahead and write 2, 6 right there. Now, I want to find an equivalent fraction using the tape diagram. So what I'm going to do is I thought it would be kind of fun to split everything in half. Because, you know, when we split things in half, it's kind of like sharing with a friend, right? So I want to take each one of these unit fractions and I want to split them in half. Now, as we talked before, when I'm showing it on the tape diagram, if I'm going to split it in half, I'm going to use a dashed line, okay? So I want to take this 1/6 and I want to split him in half. So I'm going to take a dashed line and I'm going to split him in half. And since I did it to him, I got to do it to everybody else, okay? So let's go ahead and split this bad boy in half. All right. And pencil down to show me that you got that done. We are proving, according to our standard, that we can use a model to show why fractions are equivalent, okay? The whole piece, did it ever change?
No.
No, it didn't change. The shaded, when we proved that these two fractions are the same, did the shaded part change?
No.
No, so they are still the same. That candy bar, fantastic, wonderful Hershey candy bar. When you open it up, it's a whole piece. It's got all those little sections, right? Did those little sections change when I opened up the candy bar? Nope, it's just showing that all of those pieces are equivalent to the whole candy bar. Okay? So, you ready to try some on your own?
Yes.
Well, we're going to do it anyway, so I'm just saying. All right, let's. We are proving, according to our standard, that we can use a model to show why fractions are equivalent, okay? The whole piece, did it ever change?
No.
No, it Didn't change. The shaded, when we proved that these two fractions are the same, did the shaded part change? No. So they are still the same. That candy bar. Fantastic, wonderful Hershey candy bar. When you open it up, it's a whole piece. It's got all those little sections, right? Did those little sections change when I opened up the candy bar? Nope, it's just showing that all of those pieces are equivalent to the whole candy bar. Okay? So, you ready to try some on your own?
Yes.
Well, that's where we're going to do it anyway, so I'm just saying. All right, let's. I've heard that before. Yeah. That's right. We're looking at the fractional pieces. That's right. Decompose the shaded fractions as the sum of the smaller unit fractions in at least two different ways. Okay, so we are going to prove that they are equivalent fractions. We're going to show a way to show an equivalent fraction. All right. So A, what is my first step of A? During your work period today, first you had to decompose, right?
Yes.
So we decomposed a diagram that was already given to us, all right? So we're going to take that and use it towards our strategy. So the second part of our work period was actually proving, okay? So now, just out of curiosity, I know this is kind of a silly question. Who used the tape diagram to prove? Yes, I think kind of what the assignment was. Very good. Very good. Who looked at the relationship between the denominators? Now, what does the relationship between the denominators actually tell us? What does it actually tell us, Xavier? How many lines or how we have to separate it, right? So that relationship. Now, I have two different fractions. They don't look alike. 1/2 doesn't look like 2/4, does it?
No.
But when we put it on that diagram, we can actually see that they are equal or equivalent. Very good. So going back to our standard really quick. Equivalent fractions. We know that A over B, okay, our numerator and our denominator can be represented differently, but actually the same. All right? So does anybody have any questions, any concerns or anything like that? This is a fantastic tape diagram strategy. And once again, since we're putting this on film, Miss Blunt will be your best friend if I can send all of you to 5th grade already knowing how to do the tape diagram. Okay. Been proved, two fractions are equivalent by using a model. You know what? Turn and talk 15 seconds, go. We're going to come up with an awesome answer. How can you prove two fractions are equivalent using a model?
Take diagrams, so like they are right each other, draw the fractions and then see if they're similar.
3, 2, 1. All right, so the question was, how can you prove two fractions are equivalent using a model? How can we prove that two fractions are equivalent using a model? All right, Danielle, you look like you really want this one.
Well, you have to use a tape diagram. That's how you can show that it's equivalent. And if you like break it up into pieces and your time to multiplication.
Well, she's throwing all those pieces in there, isn't she? What do you think, Miss Sistrunk? She says by using that tape diagram, you can actually show that they're equivalent by showing the pieces that are together during that shaded part.